So, good evening, all of you. My name is Arun Sharma, and today we will discuss about the question paper of Neet or G. There is first question of grade 12th. The three infinite long charge sheet are placed as shown in a figure. Means figure is given. Show the electric field at the point P. The question is find the electric field at point P. This is the question paper is given for J or need student. Need student. The question is given here Z is equal to 3A. Sigma is the charge density is given, and there is another, right? Z is equal to A and minus 2 sigma density is given. So, this is your x axis, and at the x axis, it's a sigma, a minus sigma, and Z is equal to A. And here is the point P. Point P is given. So question is asked the electric field at point P. In this direction, Z is given. Z is given. So the question is the electric field at point P. Option is given. A option 2 sigma upon epsilon 0 unit vector K. B option is given minus 2 sigma upon epsilon 0 unit vector K. C 4 sigma upon epsilon 0 into unit vector K, and D option is given minus 4 sigma upon epsilon 0 into K. These are the four option is given, and the question is find the electric field at point P. So the electric field at point P. If we find in this direction, so about the electric field due to a infinite, it's a infinite plane sheet of charge is independent on the distance. It is independent on the distance of the point P from the charge sheet, and applying the law of principle of conservation, yeah, superposition of electric field, the total electric field at point P due to the various plane charge will be equal to, it means you will find the electric field. So here E, the electric field at point P is equal to first point sigma, this sigma upon 2 epsilon 0, because it is in opposite direction, so we write here minus k unit vector, and the second one plus plus 2 sigma upon 2 epsilon 0 minus unit vector k, it's a minus unit vector k, and then last this one is sigma, mean plus sigma upon 2 epsilon 0 unit vector k. So if we sum these vector, so the electric field at point P is equal to minus 2 sigma upon epsilon 0 into unit vector P. Which option is the right? I think minus 2 sigma upon epsilon 0. This option is the right. B option is the right. So you know how to find the electric field at point P. So next question is the electric dipole. You know what is an electric dipole? The distance between two equal and opposite charge is called electric dipole, and electric dipole moment is represented by p vector, and it is the product of charge and distance between the two vector. Means the formula is p is equal to q into 2a. This is electric dipole moment. But the question is asked, an electric dipole consists of two equal and opposite charge, each of magnitude 1.0 microcoulomb, separated by a distance of 2.0 centimeter. The dipole is placed in an external electric field of 10 raised to power 5 Newton per coulomb. The maximum torque on the dipole. So you know the formula. Torque is equal to 2a pe sine theta. Yeah, torque is equal to p vector cross e vector. So it's a cross vector. It means torque is equal to pe sine theta. So you can apply this formula. So first of all, uh, so you understand the question. What is the question? The question is find the electric dipole. Question is given, and the magnitude of the charges is 1.0 coulomb by a distance 2.0 centimeter, and option is given. A option is given 0 0.2 into 10 raised to power minus 3 Newton into coulomb. B option is 1 into 10 raised to power minus 3 Newton into meter. C option is 2 into 10 raised to power minus 3 Newton into meter, and the D option is 4 into 10 raised to power minus 3 Newton into meter. This will give us. So how to find? So you know the formula. Uh, if we find the maximum torque, that is equal to p vector cross e vector. This is the formula. So torque is, if we remove the vector, pe sine theta. So pe sine theta. So if we find the electric dipole, this will electric dipole. It is the product of charge and distance between the 2 point charges. So we write here torque is equal to Q into 2A into E. This will solve. P is equal to Q into 2E into sine 90 degree. So sine 90 is equal to 1. Torque charge is given 10 raised to power minus 6 multiply by 2 into 10 raised to power minus 2. This distance is given, and the electric field is 10 raised to power 5. Sine 90 is equal to 1. So this will 6 into 2, 8. 8 and plus 5. It means 3. So torque is equal to 2 into 10 raised to power minus 3 Newton into meter. It means the C option is the right answer. Clear? So move on the third question. The third question is, wait a moment. Listen carefully. The third question, and pause if we you can write the question, or just you pause. The question is, a ring of radius r, one ring, radius is r, carries a charge capital Q. मीन्स एक रिंग है, और रिंग के ऊपर रिंग का जो रेडियस है वो आर है, कैपिटल आर, और उसके ऊपर चार्ज कैपिटल क्यू है. यूनिफॉर्मली डिस्ट्रीब्यूटेड इट्स सरकमफ्रेंस में डिस्ट्रीब्यूट किया है. एंड व्हाट इज द रेशियो ऑफ इलेक्ट्रिक फील्ड strength at the distance r, that of distance r by under root 2 along its axis. So understand the question. One ring, radius r, charges capital Q, and it is distributed along the circumference. जो सरकमफ्रेंस है उसके ऊपर चार्ज जो है कैपिटल क्या हुआ, रेडियस आर गिवन है. तो रेशियो निकालनी है आपने, और स्ट्रेंथ का डिस्टेंस आर, और दूसरा डिस्टेंस अलोंग द एक्सिस आर बाय अंडर रूट 2 इज गिवन. सो ऑप्शन इज गिवन ए is equal to under root 3 by 8. B option is given 3 under root 3 by 8. C option is given 3 under root 3 upon 4 under root 2. And D option is 2 under root 2 upon 3 under root 3. First of all, you know the question. What is the meaning of the question? Then you understand how to solve the question. So here, the electric field at the point. First, in the first question, you know, the option C. Second is also C. And then, how to solve the electric field at the point on the axis. One ring, the charge is distributed, radius is R, and capital Q charge is distributed along its circumference. So, E is equal to 1 upon 4 pi epsilon 0. You can write here K and Q. X distance. First is X distance and second one is R by 2. Sorry. Second distance is R by under root 2. So Qx upon X square plus R square raised to power 3 by 2. You know the formula of this. You know, this is your ring. This is your point P. This is your X. This is your R. And the charge is distributed. This is uniformly cross-sectional area AB. And this is your elementary portion DL. So we will find the electric field. So first of all, this formula we can apply, and here radius r of the ring, if x is equal to r, suppose x is equal to r, then this x is equal to r. E is equal to 1 upon 4 pi epsilon 0 QR upon r square plus r square raised to power 3 by 2. Understand the question? So, if this distance is equal to r, it means E is equal to 1 upon 4 pi epsilon 0 QR upon 2r square raised to power 3 by 2. Understand, r square is equal to 3 by 2. This is your first case. If the distance is x and the second distance is given, that is r by 2, mean x is equal to r by under root 2. This is the second option. This is the first option. So how to find? Means E dash, hope you can see, E dash is equal to 1 upon 4 pi epsilon 0, and the charge is given Q r by under root 2. This charge is given r by under root 2. It means r by under root 2, r by under root 2 का whole square plus r square raised to power 3 by 2. Understand the concept? So this will be equal to, move on this point, this will be equal to 1 e is equal to 1 upon 4 pi epsilon 0 and r square under root 2 r square, it means it is equal to qr, it is equal to qr, sorry 2qr, it is equal to 2qr divide by r square, r square 3r square, 3r square raised to power 3 by 2. This is the second case. And the examiner asks what is the ratio of this? Mean E by E dash. So just we erase the option, first option or second option. So you understand. So you can put the value here. In the first case, that is equal to 1 upon 4 pi epsilon 0 qr upon 2r raised to power 3 by 2 divided by 1 upon 4 pi epsilon 0 2qr divided by 3r square raised, sorry, raised to power 3 by 2. Wait. This one. Raised to power 3 by 2. So understand this concept. It means here QR remain cancel out, and here 3 raised to power 3 by 2 to cancel. So after that 2 and 2 raised to power 3 by 2, clear? So it means this will be equal to 3 under root 3, 3 under root 3, and 2 into 2, 4, 4 under root 3. It means your C option, 3 under root 3 by, sorry, here the option is, I think we write here 4 under root 2. So answer is 4 under root, sorry, 4 under root 2. Sorry. So it means this option is right answer. 2 square 3 by 2. Clear? So this is the concept of your question number 3. So move on the question number 4. So question number 4 is a infinite long straight wire. Infinite long straight thin wire has uniform linear charge density. You know linear charge density of 1 by 3 coulomb per meter. Then the magnitude of electric field intensity at the point 18 centimeter always is. Mean one is a straight wire. Uniform charge density is 1 by 3 coulomb per meter. So you know the formula of electric field intensity, that is equal to 1 upon 4 pi epsilon 0 2 lambda by r. So we can find the lambda, and then uh, unit of lambda, mean perpendicular distance of the r. So first of all you listen the question carefully, after that you solve. One is a straight wire, straight thin wire. So it means E is equal to 1 upon 4 pi epsilon 0 to lambda divided by R. So here R is the perpendicular distance of the point of the wire. Lambda is given 1 by 3 column per centimeter. The radius is given 18 centimeter. So it will be converted into meter. 18 into 10 raised to power minus 2 meter. This is the wavelength. So we write here 9 into 10 raised to power 9 2 multiply by 2 into lambda. Lambda is equal to 1 by 3 divide by uh, radius is given, r is given 18 into 10 raised to power minus 2. So you can solve this. Uh, this is equal to, how will you solve? 9 into 2, 18. 27 mean 1 by 3 into 18, 18 cancel, 18 cancel, and 10 minus 2, it mean plus 2, it mean 10 raised to power 11. 1 by 3 into 10 raised to power 11 Newton per column. What the option is given? So many option is given. 3.33 Newton per column, 1.67 Newton per column, so 0.33 Newton per column, and last is none of these, A, D, and C. So this will be equal to 0.33 into 10, sorry, into 10 raised to power 11 into 10 raised to power minus 10 into 10 raised to power minus 11. So it is equal to 10 raised to power 11 Newton per column. This means, it means your C option is the right answer. After that, your last question we solve. Uh, this is your fifth question. Two charge, 2 point charge are 3 centimeter apart. There is two charges given and 3 centimeter apart, and their combined charge is 8 microcoulomb. The force of a repulsion between them is 0.012 Newton. Charge R. Charge जो given है. First option 4, 4 microcoulomb. Second 5 into 3 microcoulomb. Third 6 into 2 microcoulomb. And fourth one 7 microcoulomb. 7, 1 microcoulomb. Understand again? There is 2 point charge 3 meter apart, and their combined charge is 8 microcoulomb. The force of a repulsion between them is 0.012. Force of a repulsion is given. So here we write here. First of all, you understand the question. First charge Q1 is equal to Q microcoulomb mean 1 microcoulomb, and Q2 is equal to 8 minus Q microcoulomb, and R is given 3 meter. Force is given 0.012 Newton. These values are given. So you know columns law. F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon. So this formula is applied here. F is given 0.012 is equal to 1 upon 4 pi epsilon 0 mean 9 into 10 raised to power 9. So Q1 mean Q multiply by 8 minus Q. Clear? This is the charge is given. Micro column you can write here. Micro. You will solve micro column. Micro into 10 raised to power minus 12. So after that, the radius is given. R is given 3. So 3 whole square mean 9. So how to solve this? 0.012. This is the force is given. So 9 3 square 9 is cancel out. So here Q is equal to Q into 8 minus Q into 10 raised to power 9 and minus 12 minus 3. Clear? Minus 3 10 raised to power minus 3. It means Q square, you will find the value of Q minus 8Q Q square minus 8Q plus 12 here plus 12 is equal to 0. Understand how to solve? This is the mathematical portion. So on solving the quadratic equation by quadratic equation, so we will get Q is equal to 6. By quadratic equation, Q is equal to 6 and or 2, and charge mean by quadratic equation, charge is equal to 6 microcoulomb and 2 microcoulomb. So this is the right answer. 6 microcoulomb and 2 microcoulomb. Understand how to solve these value. After that, so wait 1 minute. Just a moment. This is the first chapter of grade 12. So one more question for you. In the next class, I will share on the class on the Zoom. So you, this is the question for your AIMS 2003. Question is: an electron is moving around a nucleus of a hydrogen atom of a circular orbit of radius r. The column force F between the two is, mean they ask for column force. Question is given: an electron is moving around a nucleus of hydrogen atom in a circular orbit of the radius r. A option is given k e square upon r cube into r vector. B option is given minus k e square upon r cube into r vector. C option is given k e square upon r square unit vector r, and D option is given minus k e square upon r cube into unit vector r. These four options is given. Mean the electron is moving around the nucleus of hydrogen atom in a circular orbit of radius r. Then what is the column force? So you know the charge. You see the all the option. Mean charge on the hydrogen atom is plus E and charge on the electron is minus E. Charge on the hydrogen atom is plus E and electron is minus E. Understand? So if the charge is plus E and minus E, minus sign show that the force is attractive. Force is attractive. So F is equal to minus 1 upon 4 pi epsilon 0 E multiplied by E upon R square. So here unit vector R, you know how to solve this unit vector. Unit vector is equal to R vector upon magnitude of R. Yes, simply we can write here R. So this will be equal to, what is a column force? F is equal to minus 1 upon 4 pi epsilon 0 E square. If we solve this uh, upon R square, R vector upon R, so F is equal to minus K E square upon R cube into R vector. So see which option is the right answer. Here is the R vector. Here is the unit vector. It's wrong. There is no negative sign. Wrong. It's a negative sign E square upon R cube into R. It means your B option is the right answer. This question is aims in 2003. Clear? So one more question, like a dimensional formula. One question for Neet or J. There is one question is a dimensional formula. So question is given using mass capital M, length L, time T, current in ampere as a fundamental quantities. The dimension of permittivity means epsilon 0. So you will find the this is the question of AIMS 2004, IIT, JEE means 2013. Listen, the question is AIMS 2004 and IIT IIT means 2013. Mean they ask for the dimensional formula of epsilon 0 permittivity. Again, we revise the question. The question is using mass m, length L, time t, current ampere as a fundamental quantities, the dimension of permittivity is mean f is equal to 1 upon 4 pi epsilon 0 q into q upon r square. This will be this is constant. you will find the dimensional formula of epsilon 0. So epsilon 0 is equal to, listen carefully, uh, here q square upon f into r square. So current I is equal to charge upon time. Charge is equal to current multiplied by time. So epsilon 0 is equal to I into T multiplied by I into T upon F, Newton's second law. F is equal to ma into R is equal to L square. So epsilon 0 is equal to I into I square, mean ampere square, T into T square, divided by M multiplied by this acceleration is equal to velocity multiplied by time multiplied by L square. Step by step we solve. So this velocity I square multiplied by T cube, T square into T cube M divided by M multiplied by this velocity is equal to displacement upon time multiplied by L square. So dimensional formula, this is 1 m minus 1 2 into 1 L minus 3 T raised to power 4, the unit of current as a fundamental unit A square. This is the dimensional formula of epsilon 0. Yeah, permittivity. So you remember the one question is JEE mains or need for dimensional formula. You know what is the exact formula and how to find step by step. So this is the dimensional formula of permittivity, epsilon 0. So my last question is in the basic cesium chloride uh, crystal, cesium positive chlorine ion are arranged in BCC configuration. In the solid state in chemistry, what is BCC? Body centered cubic crystal. The number of atom are present at the corner as well as center of the body. So, as shown in a figure, the net electrostatic force exerted by 8 cesium, 8 mean 8 corner of the crystal, like this. Like this. This question is aims 2014. Mean BCC. First of all, if you understand, there is one simple cubic crystal. Simple cubic crystal mean all the atoms are present at the corner. 8 multiplied by 1 by 8. So number of atom is 1. BCC, the number of atom ions are present at the corner as well as center of the body. It means 8 multiplied by 1 by 8 plus 1. It means number of atom is equal to 1 plus 1 is equal to 2. One more FCC, face centered cubic crystal. Mean number of atom are present at the corner as well as each face of the center. 1 by 2 mean face is 6. It means 1 plus 3 is equal to 4. What the question is asked from कि all the cesium atom ion CS positive, CS positive, cesium positive present at the corner. CS positive, CS. And one chlorine atom is present here, negatively charged. So now it is diagonally present another here. Diagonally it is present. So diagonally, if it is present here, so it means the answer is zero. Why answer the net force on the chlorine ion placed at the center of cesium ion is diagonally opposite corner is zero. Answer is zero. So you understand this concept. This is the concept of chemistry in solid state. Solid state. To understand, all the cesium atom are present at the corner and chlorine atom are present at the center. So diagonally it is cancel out. So answer is 0. So thank you. So after that we solve next question of this chapter in the next class. Thank you. God bless you.